So in this unit, we're going to get away from linear equations a little bit, and we're going to start talking about simplifying polynomials by adding and subtracting them. So what's a polynomial? Well, before we start talking about a polynomial, maybe we should discuss what a monomial is. Mono meaning one. There's just one term. As long as you're taking, in this term, you're taking any number, any variable, or any number times any number of variables. And here's what I mean by that. Down here in this set of problems down here, 2x is a monomial. It's a number times a variable. 3x squared is a monomial. It's 3 times x squared. In number 2, negative 4xy is a monomial, 18xy is a monomial, negative 5x is a monomial, x over 3 is a monomial, 11x squared y is 20xy squared. Even though we have a bunch of stuff being multiplied together, there's no plus or minus signs, right? So if you put a plus or a minus sign into an expression, it's not a monomial anymore. You'd have more than one term, which is what a polynomial is. One or more monomials that are being added or subtracted. Look at the problems down at the bottom of the page. Number 1 down here is a polynomial, 2x squared plus x minus 8, and we're adding another polynomial to it. Specifically, these are called trinomials because each of them has 3 terms. So 2x squared plus x minus 8 is a trinomial. 3x minus 4x squared plus 2 is a trinomial. They have 3 terms. We know what a coefficient is. The coefficient is the number in front of the monomial. And you know what? Like terms are monomials. We've already talked about this to some degree, right? Not monomials that have the same variables with the exact same exponents. Now, in algebra, see if you can squeeze all this in here. In algebra, only like terms can be added or subtracted together. Now, in this first set of problems here, we're just determining, yes or no. Determine if the following pairs are like terms or not. In number 1, are these like terms? Well, here we have, in the first one, we only have x. In the second, we have x squared. So no, these are not like terms. We would not be able to add those together. In number 2, we have negative 4xy and 18xy. Because we have xy here and xy here, these are like terms, so yes, we would be able to add those together. And to do that, you just take negative 4 plus 18 and get 14xy if we were adding them together. In number 3, are these like terms? Well, let's look back at our definition. Monomials, well, negative 5x is a monomial. X over 3 is a monomial. So they're both monomials. They have to have the same variables with the exact same exponents. So they are. These are like terms. Now, here's another question. What's the coefficient of negative 5x? If you said negative 5, you're correct. Now, what's the coefficient of x over 3? If you said 1, that would be incorrect. The coefficient 1 would be written 1x or just simply x. When you have x by itself, 1 is the coefficient. If you said 3, that would be incorrect, because if the coefficient were 3, then it would say 3x. And again, that's not what we have. There is a 1 in front of the x, though. There is a 3 in the denominator, so the coefficient there would be 1/3. Number 4, are these like terms? No, because this one has x squared, this one has y squared. And number 5, these are not, because this has got an x squared. So no, these would not be able to be added together. In number 1, we're going to find each sum. And think about what's going on here. Look at this. That sign says we're going to take this thing and we're going to add to it this thing. So add like things together. What you're going to do here is always start with the highest exponent of x first and work your way down. This will put it in descending powers of the variable. We'll talk about that later. Anyway, what you're going to do is you're going to add the things that are the same. So I'm just looking at this right here, 2x squared, and I'm going to combine it with minus 4x squared. 2x squared minus 4x squared is negative 2x squared. X plus 3x is plus 4x. Negative 8 plus 2 is negative 6, and you've just added your first two polynomials here. In number 2, 3p squared plus p squared is 4p squared. Negative 2p minus 7p is negative 9p. 3 plus 7, positive 10. Number 3, 6x squared plus x squared is 7x squared. 3x minus 4x is negative 1x. I just write minus x. The only thing you have left over is the minus 3, so you're done. In number 4, x squared plus x squared. Well, the coefficient here is 1. The coefficient here is 1. 1 plus 1, 2. 2x squared. Then I'm going to do with the 2xy minus the xy. Here's a 2. Here's a 1. 2 minus 1 is 1. Positive 1, so plus xy. Y squared minus 2y squared. 1 minus 2 is negative 1y squared. Number 5. Add all of your x squareds together. Add their coefficients. 2x squared plus 5x squared is 7x squared. 7 minus 1 is 6. 6x squared. Negative 6 plus 2 is negative 4. Negative 4 minus 7 is negative 11. Now notice on number 5 that I have an x squared term here, right? Well, is there an x term? Now, I didn't say x squared. They're different, aren't they? I have a 6x squared. I have minus 11. And what's the x term? Well, there are 0 x's. So I don't write any x's. I write 0 of them, right? So there is an x squared term. There is an x term. There's the constant term. But we don't write the x term because there aren't any of them. Which brings me to number 6. When you take 2a and you minus the 2a, how many a's are there? Well, 2 minus 2 is 0. So how many a's am I going to write down? 0 of them. Do not write down an a, because there aren't any. 2 minus 2 is 0. I'm going to write down 0 a's. So I don't write down anything for them. In other words, class, they cancel out. Negative 4b minus 1b, negative 5b. Negative 1c minus 4c is negative 5c. And that's how you find the sum of any two polynomials. But now let's talk about the difference. Write this down. Change, subtraction to addition. And here's what you're going to do to do that. Make the minus sign a plus sign, because now we're subtracting, aren't we? We'll change it to a plus. When you do that, everything in the second parentheses changes. In the parentheses here, that's a positive 3x, isn't it? Well, it becomes a negative 3x when you change from minus to plus. And the minus 5 changes to plus 5. So now you're just simply adding like terms. I have 9x, negative 3x, minus 3x is 6x. I have 2, this is now plus 5 is positive 7. Change the minus to a plus sign, and all signs in the second parentheses change. This is now a negative 2x. The plus changes to a minus, the plus changes to a minus. Combine like terms. 3x squared, I'm going to jump over everything and go to the minus x squared. 3x squared minus x squared is 2x squared. 2x minus 2x, again, they cancel. There aren't any x terms. Negative 6 minus 3 is negative 9. Page 2. Change the minus sign to a plus sign and change all the signs in the second parentheses, meaning this one goes to plus, this one goes to plus, this one goes to minus. And now you're adding like terms. So when you're doing your assignment on this, make sure you copy the original problem first. Show your work. Don't make your teacher guess as to whether you know what you're doing or not. Show what's going on so that in case and when you do make a mistake, your teacher can correct that for you. Can show you what you're doing in order to get a wrong answer. They can help you out in getting the right answer. So copy the problem and show your work. All right, so here's, if you'd copied the problem down on your paper, from the book, you would have written this down and then changed everything like I did right here. And I have 8x squared plus x squared is 9x squared. Negative 4x plus 2x is negative 2x, and negative 3 minus 5 is negative 8. Change the minus sign to a plus sign and change all the signs in the second parentheses. Makes that plus 7x squared, plus 2x, and then minus 4. So now I have 6x squared plus 7x squared is 13x squared. I have negative 5x plus 2x is negative 3x, and plus 1 minus 4, negative 3. This minus sign is only for this parentheses. This minus sign is only for this parentheses. So when I change this minus sign to a plus sign, it only changes the minus x squared to plus x squared and changes the plus y squared to minus y squared. This minus sign goes to plus and makes that a negative 3x squared and a plus 2y squared. Now we can go through and just simply add our like terms. X squared plus x squared is 2x squared. 2 minus 3 is negative 1, negative 1x squared. Y squared minus y squared, those guys cancel out. You're left with plus 2y squared. In number 1, down here at the problem, story problems. Well, listen now, what are we supposed to do? Well, underline, write an expression, because that's what you're asked to do. We're only writing an expression. Does it say to solve anything here? No, just write the expression. That represents the perimeter. Circle that. Key word, right? Now, a little while ago, we had a formula that showed perimeter of a rectangle. What was it? We were doing 2 times the length plus 2 times the width equals P, perimeter. So that's the formula we have to use. And it looks like this is the length, and it looks like this is the width, the longer side being the length, the shorter side being the width. These expressions are going to go in for these parentheses here. So I'm going to have 2, and then the x squared plus 3x minus 2 goes here. And then I'm going to have plus 2, and then the width is 2x plus 1 equals the perimeter. So once I simplify all of this, I'm going to have my expression, because whenever you write an expression, automatically, class, it means you want it in simplest form. And what does that mean to write an expression in simplest form? Number one, get rid of the parentheses. Number two, combine like terms. So how are we going to get rid of the parentheses here? Well, we're going to use the distributive property. 2 times x squared is 2x squared, plus 2 times 3x is 6x, and 2 times negative 2 is negative 4. 2 times 2x is plus 4x, and 2 times 1 is 2. Now I go through and combine my like terms. Well, I only have a 2x squared. 6x plus 4x is plus 10x. Negative 4 plus 2, negative 2. And there's your expression for the perimeter. In number 2, if the perimeter of the following triangle is represented by the expression p, the perimeter, p is equal to 19x minus 7, find the missing side of the triangle. Well, before we tackle this problem, let's think about this. Draw another triangle down here. And what if in this triangle, we're not talking about the original problem anymore, let's talk about this triangle. What if the perimeter were, say, I don't know, maybe 25? And I don't know, let's just throw some numbers out here. Let's say this side was 12 and this side was 8. What's this side? Yeah, it's 5, isn't it? Well, how did you get that? Well, didn't you add these two sides together, and now you get 12 plus 8 is 20. Then you took 25 minus 20. Well, just because we have a bunch of variables and, numbers and all that stuff in number 2, it doesn't change the rule. You're still going to follow that same thought process in figuring out what this side is. Your perimeter is 19x minus 7. Yeah, so what? What did we do down here? Well, we added these two sides first. Well, let's add these two things then. What's 5x minus 9 plus 8x plus 3? Well, 5x plus 8x is 13x. Negative 9 plus 3 is negative 6. Let's put it in parentheses, because that's the sum of those two sides. What do you do now? Do we take this minus 19x minus 7? Oh, no, we take the perimeter. We take this one, 19x minus 7, and subtract this one. Exactly what we did down here. It's just that we're using these algebraic expressions instead. Well, how do you subtract a polynomial? You're going to change this to a plus. This becomes minus 13x, and this becomes plus 6. So now just go through and combine like terms. 19x minus 13x is 6x. Negative 7 plus 6, negative 1. Let's do a negative 1 and not a negative 7. Minus 1. And this is that missing side. Now, if this did not make sense, rewind this, back this video up so you can catch all this, because I'm telling you right now, this will be on your test. Good luck on your assignment. I'll see you in class.